if you ever run into integrating just ln, I'll let you remember that. What is the integral of ln x dx? X ln x minus x. I'll let you just do that, okay? You don't have to do parts on that one. But you do need parts for the first section of this, so you should be comfortable doing that one. You should be. Are you okay with doing that one? You good? I put this one up there just so you remember your basic integration tools. Just because you have hammers doesn't mean you always have to use them. You can use just your hands sometimes. On this one, what is the easiest way to do it? Can you do parts on this one? Sure. Is it a lot more work and is it unnecessary? Yes. Instead, say w is equal to what? So that also tells you dw is equal to negative dx. And that also tells you x is equal to what? 1 minus w. So when you make this substitution, you end up with, oh, dx is, so negative dw. But what is x? Oh, it's right there. So you have negative 1 minus w times the square root of w dw. I've seen too many people try to use parts on this. What can you always do, like right here? Just multiply it out. So you have the integral of w to the 1/2 minus w to the 3/2. Is that something you should be able to fly through? Yep. So you have negative integral is that 2/3 w to the 3/2 minus 2/5 w to the 5/2 plus c. Are you done? Not really, because what does w equal? 1 minus x. So what do you have here? You can get rid of that parenthesis and make it what? Plus 2/5 1 minus x to the 5/2 plus c. So I put this there because you need to always remember, for example, if you can factor, try to. If you don't have to multiply something out, don't. If you can multiply something out and do the integral, absolutely. This is related to that, I don't know what to call the set, but remember limits, everybody? You've done limits a bunch of times? What's the first thing you always check if I give you a limit problem? What's the first thing you always check?
If it diverges.
No, well, that's what you're testing. You want to know if it diverges or converges. What's the first?
You test for like that formula?
No, they're super easy. You always test to see if you can just plug in the number. Sometimes I'll give you a terrible equation. Be like, man, do I need to use L'Hopital's and then factor and then use all this crazy stuff? No. Sometimes you just plug in the number and you're done. So don't forget that. Okay, stay in your same groups. Question number 2. Question number 2. Here we go. Question number 2. Go. It's right there. Back to the board. This you should end up with negative 6t squared plus 2 over 3t squared plus 1 cubed. It's cubed. You get a squared from the quotient rule and that 3t. Oh, you can't see it. Sorry. Where is it? Okay. Oh, you can't see it. Good. So then you plug in negative 1. What? Negative 1 into that? No. T equals 1, right? At t equals 1, what does it come out to be? What does the second derivative of y with respect to x become when t is equal to 1? Negative 1/16. So therefore it's what? Concave down. It's concave down. Woohoo! Okay, do not write anything down. Put your styluses down. Let's just do this one out loud. Take a look. So what's the first point? 0, 0. And what's the second point?
232.
232, right? What's the distance between those? Let's see, a to b. What's the distance from a to b? Square root of 2 squared plus 32 squared, which is definitely greater than what? 32. So did we need to use an integral to figure that out? Did we have to use it? No, we didn't. So remember, a couple of these questions are purposely chosen so that to show you, you don't always have to use the new methods. You don't always have to use the new methods. F prime of x squared dx, yep. And if the other one's the other one, if x of t and y of t, so parametric, and its time equals t equals a to b, what's the integral? A to b of what? Yeah, or I put it first. So dx dt squared plus dy dt squared dt. Yes. Yeah. And it's 2 Pythagorean theorem triangles. That's it. That's all it is.